When I was little, I had a habit of doing that. I would take a drink. So laughing.
Screw that way.
Hey, no.
All right, let's go. Number 5.
No, I don't have time.
What?
Are we gonna have a little bit of work time?
Today, probably not, but the rest of the week is 4.327. I'm not going to finish today because I'm going to get all the way up to work problems. I'll do work problems tomorrow. And then Friday after the quiz is a work day. Okay, so
Wait, Friday? That's Saturday.
Friday after the quiz.
This is 4-2. And you wrote it up to there, right? Huh?
All right, so if I'm looking at number 5, which is one of the basic ones, it says write all 6 trig functions, correct? So, should I find the other side first? How do I find the other side?
A squared plus B
The
squared.
diagonal theorem, which you guys should know. Which ends up being 8 squared plus 36, or sorry, 6 squared. Right, so which just equals 100. Again, you guys should be able to do that part. That's nothing new. You've seen it and you've done it. So now what?
So you start with sine, so the opposite over hypotenuse. So 6 over 10.
Sine up there, 6 over 10, right?
Yeah. 3 over 5.
And then just list them all out.
Would you need to simplify that to 3 over 5?
Yeah, when you guys actually grade it, it does simplify it. So let's go ahead and simplify it. So it's just 3/5, right? Let's do cosine of theta. It's going to be 8 over 10, right? This is opposite over, or adjacent over hypotenuse. It's 4/5. Tangent's what?
Opposite over adjacent.
Opposite over adjacent.
6 over 8.
6/8. 3/4. That's 3. Then our next one will be cosecant, right? And cosecant of theta is equal to what?
What did I tell you about that word?
Huh?
So what did I tell you about that word?
Cosecant?
No. Theta.
Theta.
No.
Theta? Man, it slows my whole progress down. Cosecant of our angle, theta, is equal to what? Hypotenuse over opposite. So that's going to be 10 over 6.
What? Wait. Yes.
So that's going to be 5/3. Then secant 10 over 8. Right? So that's going to be 5/4. And last is cotangent. And that's equal to 8 over 6. Is that all of them?
I don't know. Yeah.
Is it just a flip though? The other 3? The second group of 3 is just a flip of the first 3. That's it.
Are we gonna have to memorize those,
But that's why it's on your unit circle. Actually, no, you won't have to memorize them, but you'll spend enough time with them that hopefully it just becomes natural. You'd be surprised how many problems I assign. What? You have plenty of time. All right. So that's an easy one, right? Is that pretty basic? Okay, let's move on to another one. Then. I'm not going to do 10 through 12 because those are the same idea. I'm also not going to do 14 because that one you just draw a line. All right. I'm going to skip 22 through 30 because if you look at 22 through 30, all you got to do is fill in the table. That's it. All right. All you have to do is fill in that table of those values. And if you want to get that table, it is on page 301. Basically, you're going to copy page 301 down into that table. I'm not lying.
No, you're lying.
What number are we doing?
How much?
I'm not doing any numbers. I'm explaining problems I'm not doing and explaining how to do them.
What number is that? Oh, for this table, it's going to be on page 301.
For the most part. We have to do some figuring out for the other ones, but they're not that bad. Okay? Now, let's do a harder one. Let's jump to 31. Gives me some information, gives me sine of 60 equals square root of 3 over 2, right? It does give me cosine of 60 equals 1/2. We want to find A, which is what? B.
Did you write down this part? Write this on the back.
C.
Everything that's on here. Write it smaller than I did though.
And D. Okay. It tells you the directions tell you to use your invert or cos identities, correct? It says use given function value and trigonomic identities. You guys can do that, or you can use the method I'm about to show you, which is a lot easier. Draw a triangle first. Just draw a right triangle. And call this angle 60 degrees. Now, based off the information it gives us, can we fill in our triangle?
Wait, why 60?
Because I have sine of 60 and cosine of 60.
Oh.
So with sine, it's opposite over hypotenuse, so square root of 3 over 2. And cosine is adjacent over hypotenuse, right? So that means this is just 1. From that, can you guys fill in the rest of your answers? Could you ideally get sine of 30 then? Because if this is 60, what does this have to be? 30. And then you can just do the ratios again, right? That seem pretty basic?
No,
Which part?
I don't know. The whole thing. And
I'm given these things.
yeah.
So what I do is draw a triangle.
Uh-huh.
I label one and move 60. I know sine is opposite over hypotenuse. Opposite over hypotenuse. And then just plug them in. Opposite, hypotenuse. Still nothing?
No.
You want me to
I
go
don't
on?
know what sine of the 30 is, or sine of
Do it
30.
again at the beginning.
Sine of 30 is going to be what, guys?
Opposite.
Sine of 30, opposite of our hypotenuse, so it's just 1/2.
Oh, okay, just kidding.
Wait, why is it?
Because
Okay,
the
you lost me
opposite,
there.
okay, the opposite of that angle
Yes.
is 1,
Yes.
and the hypotenuse is, yeah, that thing is 2.
That's your basic geometry, right?
No, I had you and then you lost me.
Where did I lose you at?
Whenever you found 1/2, like,
Okay, sine of 30, I'm looking at this one, right?
yeah,
What's opposite of it?
The opposite of that angle.
is 1.
And sine is opposite
Oh,
over
the
hypotenuse. Right? You guys can figure out the rest there, correct?
Yeah, sure.
Okay, let me give you one that's a little bit more difficult. Let's do 35.
Oh,
35.
Back then, or what?
Yeah, it's alpha. You can change it to theta. It's just a variable. It doesn't matter.
Can you just make it X?
You could use x if you want, but I try to use the Greek stuff because it relates to the radians. But you're welcome to use x. I'm going to use theta, and it's 5, right?
Wait, why are you using theta?
It's a variable.
It's
It's irrelevant.
irrelevant. What's the tangent? What's b?
Cosine,
Cosine? What's c?
cotangent.
Is it 90 minus theta though?
Oh, B is not cosine.
B's
Yes.
cosine.
Cosecant?
B's not cosine either.
Cosecant?
Yes.
C and D is cosine.
And is it cotangent of
90 degrees minus
alpha.
and this one's just theta? Or alpha? Okay, I still draw a triangle. I think that's the easiest way to do it. Label, doesn't matter which one, but label one of your angles your variable. A cotangent, when it's related to a triangle, what is the relationship? Adjacent over opposite, right?
Yep.
So 5 over what?
1.
1. Adjacent then is going to be 5 and 1.
What do you just do?
If you Pythagorean theorem, get this, which should be 1 squared plus 25, or 5 squared, which is the square root of 26 overall. Okay, cotangent has what kind of ratio? Or what's its fraction? Adjacent over opposite. And if there's nothing there, so it means it's just divided by 1, correct? So that's where you get 5 over 1. Use Pythagorean theorem, find this is the square root of 26.
Okay.
Okay? Now, these three are easy to find, correct? What about this one? Which angle would I be using?
The one on top.
I'd be using this one, because this one should be 90 minus theta.
Okay.
I'll just show you that one, because you guys can find the rest then by doing ratio stuff. I just show you that one because some people get confused by what is the 90 minus 30 mean. Questions so far? Does that seem simple? Good. Now let's do the challenging ones. Let's start off with an easy one, right? So let's do 37. The problems from 38 to 46, those are ones you're going to see at the start of chapter 5. You get a very short glimpse of them now, but 5.1, 5.2, and 5.3, we hit them really hard. So I'm giving you a glimpse of what's to come. And these ones are the easier of them. When we get to chapter 5, you don't know what it equals, you just got to simplify it. Okay? So, we need to use the trig identities for this one, which is on page 302. We're going to use those identities. I'm sorry I don't have the sheet for you today, I'll have it for you tomorrow. Okay, but we're going to use those ideas. What we need to do is try to get this side to equal that side, or this side to equal that side. Do not add or subtract or multiply or divide something from one side to the other. So if you want to put that in your notes, go ahead. Do not add or subtract from one side of the equation to the other. All right. How to do these ones? Manipulate or change the more complicated one. That's your rule of thumb. So, any ideas of how I can get tangent times cotangent to equal 1? Look on that page, see if there's any identities I could use to possibly get to 1. That is, can I change tangent and cotangent in a way? Tyler?
The quotient identities.
The quotient identities? Yeah, let's use the quotient identities. They say tangent that's what tangent's equal to, right? You're on the wrong page. So what's cotangent equal to?
Cosine theta over sine.
So we have that. From this, what can I do? Cross multiply. So if I cross multiply, what happens to the signs? They cancel, right? How does the cosines? They cancel. So what should this all equal? 1.
So what's the answer?
That's it. This is your answer. You actually have to show me your work to get the answer. Your answer is your work. Because when you guys go look to your answer book to grade it, it's going to say answers will vary.
What happened to the tangent? I'll just say answers will vary on my paper. Okay.
Tangent turns into this, based off the quotient properties on page 302.
Question. Oh, I see. On page 399. 299. Tangent is opposite over adjacent, and cotangent is adjacent over opposite. Why don't you just do it that instead of like making it difficult and having to go find that?
What?
Yeah, that would work.
No, for real,
I
come think of
know
it.
I know what you're saying, I'm saying
It's a
what?
spoon.
And
Would that
that's
work
what you-
every time?
No.
It's easier.
It will not work every time.
Why?
Doesn't
What
Coulter have
opposite
spoons in his
is-
office?
Yeah, what opposite
I
it is.
thought
No,
that.
like, you gotta just look at it. It's-
Yeah, no,
They
I-
would cancel,
It's
you
good
know what I'm saying?
Yes,
Because
I'm seeing it right here, Maddie. It's not working.
Yeah, it would work. Also,
Okay.
Because tangent is also over adjacent, cotangent.
You work every Wednesday night?
Okay, wait.
I work Thursday.
Can I do this problem another way, by the way?
Apparently. You wouldn't have said that if you couldn't.
Thank you. So the other way, I can have tangent of theta times 1 over tangent. Because if you look at your identities, is cotangent equal to 1 over tangent? So therefore they cancel out and this equals 1. There's one more way I can do it.
What if it doesn't equal one?
It tells you it equals 1.
What if it tells me it doesn't equal one?
Well, then you messed up.
Well, no.
I can do it that way too, right?
Yeah, it's the same thing.
They cancel out, equals 1. All you guys gotta do is use those properties.
Okay.
And manipulate them to get what you want on this side.
Really bad at manipulating.
And remember how I've been warning you guys all semester, this is what you have to start doing, is thinking for yourself?
No.
Using a chart to do stuff. So I don't care which way you do it, just show me one way.
Wait,
Answer my question. Why?
so those are different ways to do it, but you can do the top way?
Yep, I'm showing you all 3 ways to do it, you only have to do one.
So,
Whichever way you understand, you do it that way.
you don't understand all of them, like any of them. So you
Yeah.
still do it, right? Yeah, okay, yeah, that's right.
All you have to do is use that chart, substitute in what they mean, and plug them in.
So, wait,
Why
which
does
chart?
it make it work?
On page 302.
Why does it work?
Because you're confusing. You're confusing yourself, basically. You guys want me to do it?
Yeah.
Yes?
Can you write that down?
No,
Oh,
I'm gonna have a
wait.
sheet for you tomorrow.
Class.
So let's do 39.
Sure.
Why is cosine and secant?
Stop looking at that one. Seriously. Oh, I did it. I'm just choosing to ignore it.
But why would
You're
it
not
work?
legit answering. You're like not answering my question. Why doesn't it work? Why can't you do that way?
Because it's only gonna work for this one. It's not gonna work every time.
Okay, that's
Okay. Which side's more complicated? Right or left?
The left.
Left. So it means I need to change that one around to equal the right.
So yeah, the same way you run 37.
Which is what?
Well, do the chart and figure it out.
Okay, so what should I change?
You should change. So you can't take sine over to the other side.
Cannot take sine to the other side.
So
Is it on the
why?
Like the answer?
Yeah, in a way. Change which one?
Or why can't, I just want to know, because you told us at the beginning that we can do that, I just want to know why.
Because then it starts changing the identity of what we're
Yeah.
doing.
I thought you were supposed to be changing the identity.
You are, but you're only changing one side of it without manipulating the other side.
Okay.
Okay? Alright, tangent is something else. What can I rewrite it as? Sine over cosine. Or 1 over.
Oh,
tangent,
I
right?
get
So
what
sine
you're
equals
saying.
sine.
Which method are you using?
Use this one.
So then sine.
And then cosine cancels out?
Yeah.
Oh, see?
And there you go.
So you should have to kind of come up with your own.
Exactly.
Oh, I missed. Okay, I got it. Cause you're trying to make it 1 last time. You're trying to make it sine this time.
Yes,
I
yeah.
was trying to figure out. I was like, how can? I was like, you're supposed to like incorporate sine, but I totally get it now.
Okay, yeah, I'm trying to make the other side match the other side.
Okay.
Okay?
fair enough.
Let's do another one. So I'm gonna do all the odds in this section, so you guys get used to it. Let's do 41. Well, not all the odds, mostly. Going through the full range of motions today. Okay, what do you guys think they should do on this one?
Burn it.
Besides burning it, let's not try to be so destructive.
Somehow like the
Well,
left side.
Simplify the left side? Yes. How do I do that?
Did you use?
That's why you're here.
You have to use one of the Pythagorean ones. Huh?
We are going to end up using that.
You have to use something else first.
Yes. What do I do? What do I do here? Because this is the complicated side, right?
Well, there's a plus and a minus. Do those cancel out?
No.
Could you
What?
foil
No.
it?
Foil it.
Oh.
Nah.
Back up.
That's enough for today. Close up.
No. Foil it.
Take a 15-minute break.
Okay. So that means you get 1 times 1.
15, okay.
1 times negative sine, right? So that's just minus sine theta. Sine times 1, so plus sine theta.
Whoa, what are you doing?
Sine times sine turns into what?
Sine squared.
Sine squared theta. So it's going to be minus sine squared theta.
Is sine squared data the same as sine data squared?
No, it is not.
Theta.
They're shouting.
Theta.
Questions on that? If it was just x, you guys would do it just fine. I want you to think about it. If it was just x, you know exactly what to do.
No.
I never know when the right time to boil is actually. Ever.
If you have parentheses like this, boil it away. Okay, so we're left with,
Quadratic.
once Warren's done doing whatever back there, we're left with this, right? Okay. Those two, yes. I'm left with this right here. And I need to use Pythagorean identities. I need to use those somehow. I know the basic Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Now this is your basic one. You can rewrite this one.
It's sine squared theta minus 1 equals cosine squared theta, right?
She tried.
You tried really hard.
No, it makes so much sense.
That was really rude. Actually, I'll have you know.
What we need to do is move the sine squared over.
Oh.
I thought we weren't allowed to move things over.
Yeah.
This is the identity. In the identity I can.
What is this like?
You're like making up the rules as we go along. You're all, you know what, squares cannot be purple, but this square, it can be
Because
purple.
if I know if I give you all the rules at once, you're just gonna look at me like, what the hell?
I'm still looking at you like
I know, so I'm trying to move along. Since it's an identity, I can move stuff around. Sorry about that.
You know what this is? This is like English. It is. And all their grammar rules. Just there's a list of all the exceptions to the rule.
You see, this is on the side though, right? It's on the side of my paper.
Wait, it's not part of the problem?
It's not part of the problem.
Well, why? That's why I'm writing it. Issue. Oh, see, that's what I meant. When I said it looked right.
I know what you mean.
Wait, do you
to rewrite it like that?
No,
So what's the answer?
the answer is, this is part of your work. You got to this. Based off this, what should this equal?
What does that have to do with anything?
Yeah,
Okay.
how did you?
Let me
Yeah,
go
why
over
did
this
you
again.
even put that in?
If we knew
Stop.
that what.
Stop. On page 302.
It's in the box at the bottom of it.
There's Pythagorean identities,
Yes.
correct?
Yes.
There's one that says this.
Yes.
That identity I can change because it's not part of my problem.
Fake news.
But it is part of your problem.
Take this
It's
back
part
to
of your
geometry.
answer.
It's
Like,
Oh, why would we have to do that if we knew the whole time it was just gonna be?
Because you don't know the entire time it's going to do that.
Yeah, I have to like prove it.
No,
That's what he's saying.
I'm not asking you to prove it. I'm just asking that one to rewrite.
I'm asking more.
When I give you guys your sheet with your identities, I'm going to actually have you add the different way Pythagorean identities do it together.
I'm just gonna.
I haven't even got to the most difficult one yet.
Oh, God, we're good for today.
Let's just get that. Let's attempt it.
Let's go back to first grade.
45.
Is this the hardest one?
Yeah, this will be the hardest one.
Of the entire lesson or
Yeah,
this,
wait, what?
these ones?
Out of
You're
this
not gonna finish
lesson,
that
I would
part?
think this would be the hardest one.
What was the answer on the last one?
Yeah,
The
exactly.
one
There
line
is
right.
no
This one, there is
answer.
no answer here.
That's what
That's what we've been talking about.
Yeah, there isn't an answer, it's just.
Okay. I got an answer.
Anybody
I don't know
else?
what the hell
There ought to be an answer. There's no answer.
This is why I argue things.
All right.
Whenever you told Riley to stop when he said that this wasn't math anymore, he wasn't wrong.
True, but I didn't want you coming in already hating it and being
I would have
discouraged.
either way. So.
I just didn't
I should have
want.
just listened to Bob and Alana and not took this class.
No.
Ooh.
I have good news for you guys, seniors, though.
That too.
I was trying to get you guys out of taking
No.
the EOC this year.
But see,
I actually am.
But you
Somebody
didn't.
else who said, yeah, that makes sense.
Savage.
I talked to someone today to get you guys out of it.
That's sick.
That's what I'm working on.
seniors,
No,
we have only seniors.
So-
Yes, sir.
Seniors,
If we
back off.
take it, I'm dropping out.
God.
Now, back after taking.
What about the rest of
You guys have to take this.
Hey, Matt, the sophomore, so I'm gonna argue with you. Maybe you shouldn't have taken this class as a sophomore.
Wait, why don't you think seniors?
But I, maybe you
don't
should have
know
become
seniors?
haggard. Yeah, why you just start that? I don't know. They should be normal like the rest of us. You know, like, it's not my fault. that my parents feel like you take that class.
No.
It's not my
Sing a
fault.
goat.
My voice.
Yes.
Yeah, and did you guys
look at the pictures I took?
Yeah.
All right,
Yeah.
I'm gonna start the problem.
That was my true.
Can we start it? Let's finish it.
Which side's more complicated?
The left side.
Left-hand side.
It's a pattern we've developed here.
It's just gonna be.
You know what? I'm gonna say this in general. The left-hand side's the most complicated side.
Typically,
that up.
time, 90% of the time.
Yeah, 99%, 100% of the time.
All
Do you
right.
ever do the wrong side?
I mean, you could technically go to the right-hand side to get to the left-hand
It was too
side.
hard.
Yeah.
Oh.
What do? I want you guys to realize, my left-hand side I have addition, correct?
Yeah.
Over here I have no addition.
Yeah.
Stop shaking your head at me like that. How do I add fractions?
Same.
Common denominator.
Common denominator.
No.
So we have more.
I disagree. Sine, cosine,
Wow, guys. I need to multiply this one, top and bottom by sine. This one, top and bottom by cosine.
I understand it, but all the extra letters, they're just making me upset.
Okay.
There.
have to do that.
Little beta things are starting to look a lot like cubes lately, sir.
Not familiar with this one? I don't know how to say that, but that's, I don't understand in Russian.
Oh.
I'm Russian.
What?
I just think I don't know.
Do you never remember?
Alright,
Do you
everyone,
never?
does everyone understand that step? At least.
Not really, I feel like you just made it up.
It's like normal
It's like fractions, it's like normal fractions. If they were numbers, you guys would have to do just fine.
Yeah.
I want to make that clear. If they were numbers, you would do
But
just
they're
fine.
not numbers.
Because we have to evolve eventually.
Why?
Coulter.
You say if they were numbers, we get it.
You
They're
know-
not numbers, and that's.
This is okay because I found a loophole. You just take out pi, and there's just normal numbers. There's no numbers in that at all.
I'm aware. I'm trying to get you
Theta's
guys
not
to
even a
think
number.
differently.
That's
To realize
all
that,
words.
Can we do the next step?
next step, so I just multiply them across, right?
Yeah.
So sine times sine is going to be what?
Science
That's
data.
Plus what?
Cosine squared.
Cosine squared theta. Now, what are they all being divided by?
Sine theta, cosine theta?
Kevin just gave up.
What is sine squared plus cosine squared equal to?
One.
Equals 1.
Let's go.
Yeah, we done it for one.
72.
Yay, we did all that to figure out 1 equals 1.
Not done yet.
How does that equal 1?
Because then
The Pythagorean identities.
4 over 5 is that CSC.
I'm going to rewrite it like
No,
this
you're
now.
just not paying attention.
I get it. So I don't know what any of this means.
You didn't have to do either of those.
Is that
two
the same
things.
thing?
Yeah, sure.
If I just multiply them, it's the same thing, right?
Then there's video.
Everyone, right? It's the same thing, correct? What is this equal to?
Well, I might be able to tell if hand wasn't covering it.
Cosecant theta. Minus cosecant and cosine cosecant.
What is this one?
Secant.
Same.
Okay, is that the same thing?
Yes.
So when you guys are looking for your answer, it's all of this. If I don't see this, it's wrong.
I would have just stapled a 10.
So you are going to be grading this assignment, right?
That's a
Okay.
lot of money.
I never said it's good.
Okay.
Fair enough.
All my assignments.
Why is-
All my assignments.
Yeah, why is that?
Why did I do this?
Yeah.
So you can see that I just had this one and this one. That's
That's
fine. If you skip, guys, if you skip some steps, that's fine, because I'm gonna look through it. But don't be making shit up.
That's my special.
Okay.
Sorry, let me say this again.
Tax beta 1.
I will say, when I took this class, I made some stuff up, but I still followed the properties. If you make stuff up and follow the properties, that's fine. If you just go, well, you know what, I got this over here, and magically I end up with a tangent when there's nowhere in hell a sine or cosine, I'm like, that's wrong.
That's how I do all my math.
So I'm letting you guys know, I know some of you like to do stuff in your head. Carlos, you're out of luck.
Question.
This? Second identities.
Does that ever not equal the other side?
Okay, tomorrow I'll do more problems with you guys.
Looky, looky.